My name's Harriet. I hack your AI so the bad guys can't. Welcome back to Harriet Hacks. I'm here with a new video series for you. I guess you could call this the third series. Basically, I took a bit of a hiatus from YouTube for a while. I was focusing on the company, my PhD, the podcast, everything else going on. But I noticed that a lot of the conversations I've been in lately around AI security, I've really felt the field move so fast, and I was taking a look at my content. And, while I think the fundamentals and the theory is still the same, the field itself has moved on quite a lot. And I'm conscious that some of the content is now becoming a bit out of date. So I wanted to make sure that I still was staying relevant. I guess this is my way of making sure that I don't die on certain hills that I used to be on before, and come back to you with some fresh material on adversarial machine learning attacks, what we're actually seeing in AI security, the intersections between AI security and AI safety and how that's shifting a bit, and some of the stuff that's actually happening in the real world. So if you haven't been here before, my name is Harriet Farlow, aka Harriet Hacks. I say that I missed the boat at computer security, and so I hack AI instead. I've been working at the intersection of AI and security for about 10 years. My PhD's in adversarial machine learning and machine learning security. I talk a lot about AI security at various conferences here in Australia, where I am right now, and abroad. I've spoken at DEF CON, I've spoken at a lot of industry conferences. I run my own AI security company, which is, I guess you could call a mixture between an early stage startup and a consultancy, but we're becoming product focused now. And so the AI security space is something that is really, really changing so rapidly. And over the last year or so in my own, I guess, academic/professional life, we've been doing some research of our own. And a lot of it surprised me is maybe a strong word, but a lot of the content that I've covered before is the theory of adversarial machine learning and the things that could go wrong if you don't secure your AI systems appropriately. And so I guess what we're starting to see now, with generative AI being incorporated into businesses so quickly, everyone's using ChatGPT, everyone's using, other kinds of machine learning now as well. And we're actually starting to see what is happening in the real world, so we can move beyond the theory. And so that's what I wanted to cover today. So today I'm going to be sharing with you some of the insights about the actual attacks we are starting to see in the wild. And these are attacks that I might not have covered in previous videos because maybe they're not so squarely focused on AI security or adversarial machine learning, but they do come under that AI/security intersection enough that I think it's worth covering. Before you continue watching, if you want to support me and my channel, it really helps, I don't want to say I need compliments or a self-esteem boost, but it really does help. So if you like this video, subscribe to my channel, that can help me know that this is worth doing. Please comment on my videos and tell me what you want to see, begin some discussions. You can also find me on Instagram and TikTok at Harriet Hacks. I post short form content there. And I now have a podcast with my colleague Tanya, which you can find on Spotify and Apple Podcasts, also at Harriet Hacks, where it's a bit more maybe news-based or topical than this channel. And also you have the benefit of seeing me talk to, or hearing me talk to someone else, which can be refreshing and a change. Also for me, I struggle more and more with doing solo content these days, so please be kind. So let's get into it. We're talking about new AI attacks that we're starting to see in the wild. So basically the data that I have to support this video comes from a research project that I did through my company Mileva Security Labs. Actually, it's something that Tanya was really working on, and it's in collaboration with the Australian National University, the University of New South Wales, and funded by the AI organisation Foresight. So thank you to all of those groups. And at the end of November, we'll be open sourcing the project, so we're really keen to get your perspectives on it. But basically, the reason that I proposed this project was because I suspected that amongst all the different incident repositories that exist that cover AI incidents, things like MITRE's Atlas, Avid, AI, AAIC. There's so many. I'm going to link them below because I just can't remember all the acronyms off the top of my head, and because there are so many incident repositories now. I suspected that there might be a lot of incidents that were what I would call an AI security incident. So I'm going to do another video on this shortly, but basically I do see a difference between an incident that's caused by an AI system and an incident that actually compromises an AI system. They're quite different because the direction of attack is very different and the system itself that's being attacked is very different. And so my whole thing, I guess my beef with the field is that there are a lot of attacks on AI systems that mean that AI systems themselves need to be hardened and made robust, but this doesn't tend to be talked about as much. The dialogue tends to talk about AI systems that are causing attacks. You can think about, a deep fake. That's an example of some sort of attack that's created because a generative AI system was able to create a really convincing deepfake that can then circumnavigate other systems. Now, if that compromised an AI system, that would be an example of an attack done by an AI to an AI, but most of the time attacks on AI systems go underexplored. So that was the premise for this research. We wanted to comb through all of these incident databases and understand the split between incidents that were by AI systems, incidents that were on AI systems, and maybe incidents that weren't really related at all. Like they were traditional cyber and information security incidents that maybe didn't belong there, or maybe they weren't actually using AI. We all know companies that don't really use AI, right, but say they do. So I wanted to share some of the insights from this research with you because some of it did sort of surprise me. So the first thing we found was that most of the incidents in these repositories you would consider more of a traditional cyber or information security attack, but on a system that uses AI. And, I don't want to get into semantics. Definitions don't really matter that much. We all have the same goal at the end of the day. But the thing is, for me, that I want to encourage organizations to actually care about the security of their AI systems, like maybe before you implement an AI system, you actually think about how to secure it. And honestly, these days, that's quite a stretch. So the first kinds of incidents we found were, for example, an organization that uses a chatbot as part of a broader system offering, and that organization system is targeted in maybe a data breach, and so some of the data that would have been available to the chatbot is leaked. Now, that's not really an attack done by an AI or to the AI part of that system itself, but it's still relevant because maybe systems that incorporate AI are more likely to be targeted. Maybe there's more emerging technologies there, there's less risk management best practice in the field, and so they tend to be targeted a bit more. So here's some examples of these kinds of attacks that we found. And don't mind me, I'm just looking at my laptop over here so that I don't misrepresent anything. So there's many examples of these kinds of attacks. One I want to call out is Clearview. So Clearview AI is a facial recognition company based in America, and they provide a lot of the biometric authentication done by AI to organizations like law enforcement, policing, and security. So this is an organization that's already going to be a pretty big target, and they do use a lot of AI. And there've been a few incidents relating to this organization. Again, not a criticism of the organization itself, because all organizations are targeted. But there were definitely a few incidents in these repositories. Most of them didn't necessarily refer to the facial recognition models themselves, though. So there was one fairly high-profile incident about the data that was in Clearview's databases. For example, there were instances of children being in that database without their permission, which is a question that is going to affect all AI organizations, but isn't necessarily an example of an AI attack. And there was also another incident that was reported where Clearview AI's source code repository, although it was password protected, was misconfigured to allow an arbitrary user to register an account. This left the company's internal files, applications, and source code at risk. So an external researcher gained access to a private code repository that contained Clearview AI's production credentials, keys to cloud storage buckets containing 70,000 video samples, and copies of its applications and Slack tokens. So you can see how all of that information might help an organization attack the AI part of the systems, but this is in itself a traditional cybersecurity attack because it was through the misconfigured source code repository. So there were lots of incidents like this. And I think it's important that even though maybe this isn't strictly an example of an AI-based attack, by gaining access to all of that information, they are now able to launch AI attacks. So, they could create a surrogate model that might be really similar to the facial recognition models used by Clearview AI, and be able to create adversarial examples. I'm going to link to other videos where I've talked about adversarial examples before. Okay, so the next interesting takeaway from these kinds of incidents was, speaking of adversarial examples, if you haven't heard of this before, the idea of an adversarial example is that it's very much based on image classification. You can create adversarial pixels that, superimposed on top of an image, prevent a model from recognizing what it is, basically. And this can be either a deception-based attack, so you're deceiving the model to make it predict something else of your choosing, or it's a disruption-based attack, so you're making it just not work at all. The interesting thing about our findings from this project was that we weren't necessarily seeing a lot of these kinds of more common theoretical adversarial machine learning-based attacks. When it comes to the actual AI security attacks we were seeing things like evasion through data poisoning. We were seeing hidden payloads in model files or, AI-related files, so that could also be in the data. We were seeing things like side channel attacks, and then we were also seeing evasion attacks of the AI system itself. So not through data poisoning, but I guess through the idea that an adversarial example would have targeted sort of in the beginning. So let me go through some examples of this. So when it comes to evasion through data poisoning, there were some examples from the malware space. So for example, McAfee Advanced Threat Research noticed an increase in reports of a certain ransomware family that was out of the ordinary. And investigation found that many samples of that particular ransomware family were submitted through a popular virus sharing platform within a short amount of time. So basically the way that those models work is that people voluntarily submit examples of malware into a big data set, and then a model is trained on that data set. And so because all of the data set is open, so it's a lot easier for someone to poison that data set. And this is tough because the whole idea of seeking input from the community is that it's a good thing to have anyone from the community being able to submit data, but it does make it more at risk of a data poisoning based attack. So they found that someone used a metamorphic code manipulating tool to manipulate the original file towards mutant variants. And based on string similarity, the variants were all equivalent, and based on code similarity, they were between 98 and 74% similar. So what this means is that a model that McAfee is now training on this poisoned data would not be able to classify the malware accurately because there are so many examples of it in the data set. Interesting. The thing about these kinds of attacks is that it's also hard to spot. This was an attack that was found through internal testing from the McAfee team. And if you don't have that kind of testing, then you wouldn't find it, which is also my whole beef with AI security. If you're not looking for them, it's really hard to find. So another example is this idea of hidden payloads in model files. So an example comes from this attack on PyTorch Nightly. So Linux packages for PyTorch's pre-release version, called PyTorch Nightly, were compromised in December 2022 by a malicious binary uploaded to the Python package index code repository. The malicious binary had the same name as a PyTorch dependency, and the package manager installed the malicious package instead of the legitimate one. So basically what's happening here is that if you are downloading model files through your package manager in Python, so maybe from TensorFlow, you're just automatically getting packages imported. Maybe it's through Hugging Face as well. Basically anywhere where you're importing a package that it's dependent on the actual file name and its location. If someone puts a different piece of code or any kind of different artifact into that location, then you're going to download that. And so you can download all sorts of malicious executables because there isn't really any process of actually checking that the right files are there. And over the last year, I've been to a number of conferences as well where there have been examples of this happening in the wild that also go sort of unreported when it comes to actual papers and blogs. So in this particular example, the malicious code was able to survey the system for fingerprinting information, so it would find like the IP address, username, current working directory, and then still sensitive data based on being able to go through where your data is likely to be stored in sensitive files. So it goes through and looks for passwords, config information, files. It then uploads all of that data to a domain that is written in its code, so someone else can go and access that. This is a real worry. I think the thing about this is that maybe you could also call this a traditional cyber attack, but because it's in the world of AI, where, as I've said before, there isn't traditionally a culture or a history of security. Again, not to criticize data scientists or AI people, that's just not how we've been taught, and that's not necessarily something we've had to consider before. And so all of these kinds of processes don't necessarily have security steps in place that you would expect had the same thing been happening in a different system. So these kinds of examples were also found in many other applications too. This is a fairly common kind of attack. So Google Colab, for example, is one where you can just use Colab files, which is tough because I'm a big fan of Google Colab, also for sharing my code with people so that they can use it. So I'm still going to keep using it, but I know that Google Colab is introducing steps to make sure anything that can be executed is extra secure. And this is also found to be happening in Ray, which is an open source Python framework for scaling production AI workflows. And again, interesting, Ray's API allows for arbitrary remote code execution by design. You know, these are things happening by design that we now have to apply that security mindset to. Okay, here's another example. So we have a side channel attack. So Cloudflare addressed a side channel vulnerability in their AI product. So again, this is actually from vendor testing, which speaks to the benefit of vendor testing. And it was affecting large language models in their systems that were operating in streaming mode. So this meant that by intercepting encrypted AI chat sessions, attackers could infer the length of each token from network packet headers. This information could then be used to reconstruct portions of the AI responses. And then Cloudflare did fortunately go and mitigate this, but I think this is really interesting because this is an example of the kind of attack, like a side channel attack, happens in cyber and information security world, but to AI. And it's interesting because the kinds of information they were getting was encrypted tokens. So if you know a lot about language models, you know that the way that a language model passes information is not through text, as in the way that we know it, you know, in English or whatever language we speak, it's through numbers. And all of the words that we feed into a chatbot, for example, or a language model, are mapped to different numbers, and that's how the model passes them. So when they're executing this side channel attack, they're actually getting back those numbers, those tokens, and then there's another step that is trying to reverse engineer what those words are. But this is possible, especially because if they're able to collect enough information, then they can string together sentences. So they can, you know, see basically what people are inputting into their language models. I think this is really interesting. But again, it was found because of vendor testing. Okay, the last category of attacks I want to cover is this idea of evading AI biometric recognition. So it's somewhat related to the Clearview example I gave before, when a lot of the time these are facial recognition models that are being bypassed, but they're often being bypassed just because the models themselves aren't particularly robust. So there was an example in Shanghai from earlier this year where a couple of people were able to evade the traditional live facial detection authentication model and enable access to privileged systems and do this through victim impersonation. They then created a fake shell company and sent invoices to those clients. So they're able to buy basically just high definition photographs of faces from a black market website. They used an app to create videos from the photos to make it look like the faces were nodding, blinking and opening their mouths. And that's what's important. So I mentioned before that there was liveness detection in the facial recognition models. And this means that most models at the moment do have checks to make sure that people kind of move a bit, they blink, they're not just static photos. But these attackers were able to, take photos and then add these kinds of elements so that they were able to bypass the liveness detection. And they were then able to get into all of their accounts, wire money to their own accounts, and profit. There was also an example of this in California, where an individual filed at least 180 false unemployment claims in the state of California between October 2020 and December 2021 by bypassing the ID.me automated identity verification system. Dozens of fraudulent claims were approved and the individual received at least $3 million in payments. God, what I would do for $3 million. Not this, just to clarify. Again, I think this is really interesting because I know in my previous videos I did touch on examples of attacks where people were able to hold photos up to facial recognition models and have that work. And we're now seeing, I guess, the next iteration of attacks based on those original ones, which is really interesting. One other trend I want to touch on before I sort of wrap up is a lot of the ways that we're actually starting to see AI models introduced, and a lot of the reasons why organizations often don't care, or at least don't think that the security is their responsibility, is because organizations tend to use RAG models. So RAG stands for Retrieval Augmented Generation. So this means that it combines a retrieval system and a generative model to enhance its availability and produce accurate and contextually relevant responses. So this means that an organization would have their own internal data, and that would be sort of enmeshed with a third-party AI provider. So maybe they're using GPT, but then it's augmented with their own data in the retrieval system. So that technically they're not sharing data with OpenAI, but they're using the model. And so one of the common challenges that I get when I'm talking about this is that people think that the responsibility for their data is theirs. That's not new, that's traditional cybersecurity. But then they don't need to worry about the model security at all because of this RAG structure. The model is actually provided by someone else. And so I think this idea is, this is a really good trend, or a popular trend, and I agree, it makes sense for a lot of reasons, from the perspective of implementing AI better and easier, but also securing it. But there have actually been some examples of attacks being successful against these kinds of systems as well. And so I don't want organizations to become, complacent. For example, there's this study that introduced poisoned RAG. So it's an attack where adversaries inject malicious texts into a RAG systems knowledge database. So I guess you could call this an example of a data poisoning attack. And the goal was to manipulate the system into generating attacker-chosen responses to specific queries. And there have been a number of attacks where, because there is that dependency between the third-party AI and the internal data, and sometimes there's often a bit of a missing link or a gap in who's responsible for what, and that's where the challenge lies. Organizations need to understand that they need to know who's in charge of what, there needs to be clear accountability, needs to be clear technical mitigations put in place, and now that we have compliance obligations, you gotta understand what you need to be compliant with. But anyway, I don't want to go into those boring sort of, organizational level things with you here. I know that might not be what you're here for. So here are my, key takeaways from this video on those different kinds of attacks. So now that we're moving into actually seeing AI attacks in the wild, I know I shouldn't be smiling so much. I just find it fascinating because I've been working in this area and talking about this stuff for 3.5 years now. I was a data scientist before that, and then I got into AI security then. And so I think it's been fascinating actually, and I know that other people have worked on it for far longer, right? But it's been fascinating going through seeing my PhD in the very fundamental theories of how to compromise deep learning architectures, and then actually seeing what's happening in the wild. And I think my key takeaway right now is that AI attacks are happening. No, they're not traditional adversarial example-based attacks that we were focusing on in the academic literature. We're looking at things that are very much based on traditional cybersecurity attacks, but with different flavors depending on the AI systems we're targeting. That means we're seeing more things like data poisoning. Data breaches were already a big thing for organizations in traditional cyber, but now the ability to influence those models by poisoning the data sets is a very, real intersection between the two. Evasion attacks that are either caused by data poisoning or by something else, often supported by AI systems. So being able to counter liveness detection by using AI to, add blinking and movement and compromise the AI systems themselves, that's a really big one. And then these other, I guess, emerging trends, there's so many conversations about things like AI worms, about the difference between language models, computer vision models, signals classification models. Obviously, the conversation's still very much on language models because a lot of companies are using those first. And especially because it's easier to interact with. But I will say that AI security is not all about prompt injection and prompt engineering, even though it does tend to dominate the conversation. And the other takeaway is that most of these attacks are found because of researchers looking for them or internal testing. I would love to know how many AI attacks have gone undiscovered because people weren't looking for them, because there just isn't a whole lot of AI security related literacy. This is what I want to research next. So like I said, this research is about to be open source. Probably by the time this video comes out, it will be. So I'd love if you could take a look and let me know if there's any other insights you have, anything we might be missing. I'm going to link all of the links in the show notes. And please do connect with me on all the channels I mentioned previously. Thank you for being here. Contribute to the conversation. And if you're someone who is either trying to get into AI and or security, or you already work in them in some capacity, please contribute your voice to the conversation. I have a few more fun videos coming, and I'm looking forward to doing the journey with you. So thank you for being here, and see you next time.